Welcome back everyone. In this video, I'm going to evaluate this integral on the board. Okay, it's an indefinite integral. We have to evaluate the integral of x squared minus 4x plus 10 all divided by x squared into the square root of x dx. That is, we are integrating this function with respect to x. Okay, let's see how it's going to be done. Looking at the function, we can actually reduce it or simplify it to a simpler expression that will be easy for us to integrate. Of course, it can be simplified. So let's sort of simplify it. Okay. Now, at the numerator, I have x squared minus 4x plus 10, and at the denominator, we have x squared into root x. We can actually simplify x squared root x using the law of indices. This is what indices says. This is root x, so I can say x squared times x to the power of 1 over 2. Yes, root x is equivalent to x to the power of 1/2. So by the law of indices now, they have the same base. So it is x to the power of 2 plus 1/2. Alright, I'm adding their powers now. Okay, this 2 times 2 is 4 plus 1 is 5. So we have x to the power of 5 over 2. So everything at this denominator is now simplified to this. So I want to rewrite this integral as the integral of x squared minus 4x plus 10 all divided by this. Okay, that's x to the power of 5 upon 2 dx. I can put this in brackets if I choose to. So to do this now, what we have to do is this. I want to split the expression in bracket. See what I'm saying? This is x squared. Okay, so I have x squared divided by this, x to the power of 5 over 2. Then minus 4x divided by this again, x to the power of 5 over 2. And plus 10 divided by x to the power of 5 over 2 dx. If we decide to use LCM to simplify this, we are going to obtain this. The denominator is common, so it is accepted. All right. Now, we can still simplify further, okay, so that we obtain a form that we can easily integrate. They have the same base, okay, so by the law of indices, I can subtract the second power from the first. That's what indices say. So this is x squared minus 5 over 2. All right, this is 5 over 2. Then I have minus 4. The x, they have the same base. Okay, so the x, I have x here to the power of 1, and here it is to the power of 5 over 2. So since I am dividing, I will subtract minus 5 over 2. Okay, let me put it this way. Now for this, I can simply do one thing. This is 1 all over x to the power of 5 over 2. Okay, it is equivalent to x to the power of minus 5 over 2. Yes, so in this case, what will happen is this. We'll be having 10 times, you will agree with me that 10 all over x to the power of 5 over 2 is equivalent to 10 times 1 over x to the power of 5 over 2. Yes, because 10 times 1 is still 10. So the equivalent of this expression here now, this one, is what we have here. So times 10, that will be 10 into x to the power of minus 5 over 2. The integration is with respect to x. So let me put the x here. Alright, I can put everything in the bigger brackets to show that I am integrating all of them with respect to x. Never mind. Okay, so let's simplify now. This is the integral, the indefinite integral of, okay, what is 2 minus 5 over 2? 2 times 2 is 4. 4 minus 5 is minus 1. So this is x to the power of minus 1 over 2 minus 4 into 1 minus 5 over 2. What is it? 2 times 1 is 2. 2 minus 5 is minus 3. That's minus 3 all over 2. Are you there? Then we have plus 10x to the power of minus 5 over 2, okay, dx. Good. At this point now, we can easily integrate it. You get it? So there are times when you have to integrate a function, and the best approach would be to simplify the function first to a reduced form or to a simpler form that is integrable. All right? And that's what we are doing here now. We have reduced this expression to something very easy that we can what? Integrate. So I'm going to integrate each of them here with respect to x, each of them. So I can rewrite this integral as the integral of x to the power of minus 1 over 2 dx. That's this first one. Then minus the integral of this now. This minus is what we have here. So I'm taking just 4x to the power of minus 3 over 2 dx. Okay. Then I have plus the integral of what? Of 10x to the power of what? Minus 5 over 2 dx. Let's go now. What is the rule of integration? What does this say? The rule of integration says that if we are integrating a function ax to the power of n dx, the rule of integration says that it is equal to ax to the power of n plus 1, okay, all over n plus 1. And since the integral is indefinite, we'll add the arbitrary constant to it. So the idea is add 1 to the power, okay, to have n plus 1, then divide by the n plus 1. So in this case now, we'll have, if I'm integrating this with respect to x, it will be x to the power of minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1 minus, okay, 4 is a constant, so 4 can be brought out. Let's integrate this now. That will be x to the power of minus 3 over 2 plus 1. Okay, we are going by that rule. Divided by minus 3 all over 2 plus 1. But never mind the way I'm writing my work. Plus, okay, I think I'm free to erase this. Yes. We have 10 is a constant, so 10 can be brought out. And if we integrate this, we have x to the power of minus 5 over 2 plus 1, all divided by what? Minus 5 over 2 plus 1. And we just add an arbitrary constant to everything. So we can now simplify now. What is minus half plus 1? Minus half plus 1 is half. That's 1 half. So we have x to the power of 1 half divided by, we still have 1 half here, 1 over 2. Then minus 4x to the power of, what is minus 3 over 2 plus 1? Okay, minus 3 over 2 plus 1. 2 times 1 is 2, so minus 3 plus 2 all over 2. And that will be what? Minus 1 over 2. Okay, minus 1 upon 2, all divided by, we are still going to obtain the minus 1 over 2 here. Yes, plus 10x to the power of what? Minus 5 over 2 plus 1, what is it? Minus 5 over 2 plus 1. 2 times 1 is 2, all over 2. 2 minus 5 is minus 3. So we have minus 3 upon 2. Minus 3 upon 2. All divided by, this one will still produce minus 3 upon 2 plus the arbitrary constant c. We are still simplifying it. Let's see where we are going to end it. So simplifying this entire expression, we reduce to, these two we actually go. Okay, so we're having 2x raised to the power 1 half. We are having 1 left at the bottom, which is this one. Okay, this is it. The 2 went up, the 1 will remain. So the 1, we can actually eliminate it. Is as good as it not being there. Alright, so we still have our 2x raised to the power 1 half. Okay, there is a minus here. There's a minus here. The two minus will intersect to produce a plus. And then, if this 2 goes up, it will multiply this 4. Okay, just the same way these 2 went up, this one can also go up and we'll have 8. Alright? Then, times x to the power of negative 1/2. Now, the 2 here will go up. Okay, see, there is a minus. Minus times plus is minus. So the 2 will go up. 2 times 10 is 20. Okay, and we're having just 3 left at the bottom. Understand the principle. Then we are having x to the power of minus 3 upon 2 plus c. We can decide to take this as the indefinite integral of that very function with respect to x. We can choose to break this down in another form. X to the power of 1/2 is equivalent to the square root of x. The law of indices says that if we have a to the power of x over y, this actually is equivalent to the white root of a to the power of x. The denominator of this fraction will form the nth root, okay, and this x will form a general power. In this case now, the 2 is our y there, so we can say the square root. 2 represents square root, so this is 2 root x to the power of 1. All right, x there is 1 here. All right, so if I put 1 or I can remove it, it's still the same thing. Then this is plus. Okay, now before we can write this like this, let's simplify it further. X to the power of minus 1/2 is the same thing as saying 1 over x to the power of 1/2. That's what the law of indices says. X to the power of negative a, for example, is 1 over x to the power of positive a. That's how this is obtained. So for this now, we have x to the power of minus 1/2, which is the same thing as saying 1 over x to the power of 1/2. Okay, since we have 8 here, if the 8 multiplies it, we are going to have 8 at the top. You get the point now. So remember, x raised to the power 1 over 2 is equivalent to the square root of x. So everything here now is 8 over the square root of x. Yes. Then minus, okay, let's first of all simplify this. X to the power of minus 3 over 2. Okay. Using the same law of indices that we just applied to reduce this, x to the power of minus 3 over 2 is equivalent to 1 over x to the power of 3 over 2. The minus will now disappear. And going by the law of indices for rational exponents, this is the same thing as saying 1 over the 2 here will form a square root of what? X, all to the power of 3. That is the point. So since we have 20 over 3 here, it will now be something like this. Okay, 20 upon 3 into what we have here now. So we have 1 over the square root of s cubed. So 20 times 1 is 20. 3 times this, that will be 3 into the square root of s cubed plus the arbitrary constant. So whichever one is accepted. This gives the indefinite integral of this. Now, sometimes the technique to evaluate an integral depends on the way or the appearance of the integral. All right. So there are different techniques to evaluate an integral. We have the integration by parts technique for evaluating products, integration by partial fraction, and so on and so forth. Okay, so the technique to be applied to evaluate a particular integral sometimes depend on the appearance of that particular function. Okay, so get yourself used to so many algebraic processes so that you can be able to evaluate some certain integrals with ease. Thanks for watching this video. I hope you like it. Don't forget to subscribe, don't forget to like, and don't forget to share the video to your friends and to your classmates. I will see you in the next one.